were looking at the matrix operations in which we have seen the concatenation of matrices, right? Okay, then let's move on to the next topic under the matrices and arrays. The next concept that we are going to look first today is about the empty arrays, right? How the empty, because null is a very important concept in mathematics as well as when we write the programs, correct? So sometimes the result may be a null, right? So since we are dealing with the matrices, it's always expected that you might get, or you might end up getting up a null matrix or null array. So how it is dealt in MATLAB, we are going to see now. Okay, so the concept is the empty array. Right, empty array in MATLAB is an array with the at least one dimension length equal to 0. So one of the dimension is not there, right? So the one dimension, at least we say that okay, there is one dimension and that dimension does not exist, right? So empty arrays are useful in representing what is called as the concept of nothing, right? So we try to uh, implement the concept of what is called as nothing, right, in programs. Whenever we want to use nothing, there is nothing in that, so you call it as an empty array, right? So just hold on one second. I'm going to share the screen. Oh, sorry, I think I missed the sharing of the screen itself. Sorry about that. Just a second. Yeah, kindly check now. Here it is saying that it is getting shared. Yeah, I can see, right? Okay, our intention is to represent nothing using program. So we use what is called as an empty array, right? Let's give an example of this. Suppose you want to find all the elements of a vector that is less than 0, let's assume, and whenever I want to find how many elements in a array or in a matrix is less than 0, right? And you see the answer is nothing. There is no element in a matrix whose value is less than 0. Anyway, I'll do the program now to show you that. But this is the concept, right? Whenever the answer is nothing, I need an empty array. Okay, so just let's try to go for a program and just let's try to find out how it is done in MATLAB. Okay, right. Let me first create an array of say size 4. Okay, so let's say a is equal to, I'll create a simple array 1, 2, 3. So this is what is my array. An array has been created, and now I just want to find out the particular location where the elements of a is less than 0. So what I do, I try to use a function called find. I'll go index value is equal to, I'll use a function called find, right? And I'll say that find those locations where the elements of a is less than 0. Okay, so I know that I don't have any such element in my matrix A. So you see the answer is, this is 1 into 0, right? So the one of the element has to be 0. This is what we defined, right? Whenever we defined a null matrix or the null vector, we said that one of its dimension should be 0. Right now you see the second dimension has been uh, it is 0 as of now. you can see here, right? So because of which this is a empty. So it says that 1 into 0 empty row vector, right? In this case, there I don't have any element or any entry in this in particular table. Okay, so this is an example of what is called as a null vector. Okay, so it's represented in the same fashion even in the MATLAB. Okay, now next we'll go for the reference of multiple elements in a matrix. So uh, this is referencing multiple elements referencing. So at a given particular time, I want to refer multiple elements, right, of a matrix. So how to do that? If you remember, I think we have done that by using, say, access the first and the third element of second row of a matrix. If you remember, right, we use uh, the specific, what you call, their index, right, by using indices in a vector format. This is how you can do that. For example, let me assume that I want to read the elements of matrix A, but specifically second row and say first and the okay, I'll eliminate the this thing. The inside a this thing in a vector, I don't want to specify the comma. So 1 space 3. Okay, this has to be a normal bracket, not a square bracket outside. Okay, so just see, this is the concept. So I specify the row number is 2 and the column numbers are actually presented in the form of a vector. So you can see this is 1 and 3. So you can see here the vector has been represented in such a way that the column size, the elements column index has been mentioned in the form of a vector, right? So since I want to read multiple elements from a particular row, right, row size is fixed but column size is varying here. So using this we can do that. Let's go back and check this in MATLAB. Okay, so let me clear the variables and perform PLC first. And now first let me create a matrix. So A is equal to, let me use a magic function, say 4. So it creates a 4 into 4 matrix. Now I want to read the second uh, row, first and the third uh, element. So that's, I would just want to read 5 and 10, let's assume. So this is A of second row, comma, element size you, elements you mentioned inside a vector. So 1 and 3 of second row. So this expects 5 and 10 to be presented on the screen. So you are trying to reference multiple elements of a matrix, right? So if you specify, right, multiple elements like the whole second row, right, you just can use a colon operator over there just to indicate that you want to read everything from there, right? So let's say I want to read the third column and the second and the fourth element. Okay, so how to write that? This is A. So I want to read the second and the fourth row elements of the third column. So see, it is 10 and 15. Okay, so this is how it's going to work, right? So how to read the complete row, right? The complete row can be read by using the column operator for columns, because one complete row means all the columns, correct? So let's try to read the first row of this matrix. So that is A of first row, comma, see all the columns, right? This is the first row of that matrix. Next, if I want to read the fourth column, then A of fourth column means all the rows will come into picture. Column number is 4. So in fourth column, read all the rows. So that's the fourth column. All right. So in this way, we can read the specific rows, columns, parts of this. Again, we have one more technique to be used here. Whenever you don't know what is the actual size, anyway, we have a command called size of that matrix. Previous class we have seen that size of A means it's going to give you the number of rows and number of columns in a matrix, correct? But if at all you don't know, or you don't want to write a code for that, right? If you don't want to use it, and you want to find the elements starting from a specific index till the end, right, then also it is possible. So I create a random matrix now, let's say, and I want to read all the elements of a particular row starting from a particular column till the end of that, right? So in a second row, let's go back to the example. Say I want to read starting from 7 till 12, but I don't know, let's assume there are 4 columns in this matrix till the end, right? So you can use a keyword called end in this case. Okay, so let me show you that here itself. So I want to read a row number is second, okay, and the columns, I don't want to read all the values in that particular row. I want to start from the second element till the end. See, when you don't know what's the last element, or what's the size, right, how many number of columns you have, simply you can use this. So you see it is actually 11, 10 and 8. Let's go back and check. See, this is second row, second column till the end, right? I can do that, right? So the end is the keyword automatically detected in MATLAB to find out the dimension along that particular direction. In the sense, if you are looking at a column, it's downwards. What's the last size in the, or what's the number of rows in that case? And if you are looking at a row, right, it's going to find out the number of columns and put it at the location of end, right? So using the same technique, what should be the command I have to write to read, say, the third column, 10, 6 and 15. I want to read 10, 6 and 15, right? In that case, it has to be A of, you see the column number is 3, but I want to read second row till the end, okay, second row till the end of third column. So let's see 10, 6 and 15. All right, then right, then we can actually do the indexing with logic, right? We can use a logical function to define and to identify whether you want to point out the indexing using a logic. Okay, let's do that now. So this concept is indexing with logic, right? In such case, let's say using true and false logical indicators, right, is another useful way to index the arrays, specifically when working with something like conditional statements. All right. So what we do here is we try to say use either true or false. So use either true or false logical indicators, right? So this is used to index arrays or matrices. So when you are going to use this kind of indexing, it is very useful whenever you work with conditional statement, working with conditional statements. So for example, let's consider a scenario where we have two matrices, matrix A and matrix B. And my intention is to find out those locations where the elements of A is lesser than the elements of B. Okay, I just want to find out those locations. Right. So let's try to do that. All right. So what this is how we are going to write the command in MATLAB for this scenario. For first, let's create a matrix. Okay. So let's create the two matrices first. So let me create A is equal to 1, 2, fine. So this is matrix A, and B is equal to, let's create a similar one. So this is 2, 4, this is 5, 8. Okay, so these are the two matrices. Now I know which are the locations where elements in A, if elements in A are lesser than the elements in B. Those locations we know now. Now we use a logical indexing over here to find out whether what are the locations where the elements of A is less than B, right? So this is what we can do. Say let's do ind for index. Index is equal to, I'll simply write A, small a is less than B. So this, you see, it is going to result in an logical array, right? So logical array is is an array with the entries being true or false. So true is represented by logical 1 and false is represented by logical 0, right? So you can see here in this result, it says it is a 2 into 3 logical array, right? So 101 101, because the first row, first element in A is less than that of B. In B it is equal, in second location it is equal, third location also less than that. So first is 8, second is 9, right? So it compares each element by element for A and B and then gives you a result, but the result is a logical, right? So conditional statement, you don't have to write the whole condition like using a for loop, what we do in C programming, right? So that is not at all required. Simply use this command to get a result, right? That is represented in the logical array format. Okay, then so less than, even if even you can use the greater than, right, etc. Now I'll tell you another method, that what if I just want to find out those values which are less than that. So now you see, I came to know that okay, at these locations, right, we have lesser values in A compared to B, right? Now how to extract those values of A which are lesser than B? Is it possible? Yes, the answer is possible. So simply write A of that ind, indicating that it's index. Find out those indices where the indices are 1 and get the values. So the values are, you can see the lesser values are these. Okay, so In A, you can find 1803. Those are the values, right? In A, which are lesser than B. Or if you want to find out the bigger values than A, right? That is B of int. So this is going to give you the which are the values which are bigger, right? Compared to A. Okay. Straightforward method to find out. Always this particular technique, what we just have used now, uh, gives you a column vector. Okay, it's by default it's going to be a column vector. You can convert by taking a transpose. You can convert that answer into a row if needed. Okay, right, then let's move ahead. In the next concept, I want to show you how to remove a particular row or column from uh, a matrix. Okay, so I want to uh, removing rows or columns. Right, so we use the empty square brackets to do this. Okay, so let us assume I have a matrix and I want to eliminate the second row of a matrix, right? So this could be the example. Matrix A, I'll use the normal bracket, A of second row, right? Means all the column values. Sorry, it's a colon operator, everything, right? Second row, all columns, make it none, right? So it means you simply eliminate. Similarly, you can do this. So B of all rows of a particular column, third column, you can make it this. Like that, we can eliminate or remove the particular row or column from a matrix. Let's look at the concept in MATLAB window. So I create, say, A is equal to magic, say 5. Okay, it creates a 5 into 5 matrix. Now I say in A, I'll put it into the answer. Okay, so A of, let's try to remove the third row completely. So third row and all the columns, make it this. See, it removed the third column completely, right? Similarly, if I in this answer right now, whatever I have, I'll try to eliminate the third column. Okay, so in such case, I have to enter A of all the rows of a particular column. So column number is 3, make it null. So you see, it is right now, it's like this. Okay, this is one technique. Let's extend this further. That what if I want to remove the second and the third column, right? I want to eliminate the second and the third column of this matrix. Is it possible to do in a single step? Yes, it's possible. So it's A of, right? Mention the mention that you so first example, I'm talking about columns now. So second and third column means all the rows of, mention this, right? Like 2 to 3, make it equal to equal to null. You just see that it's removed the second and the third column elements. So first column is there and the last column is there. Now in this, very similarly, can you remove the second and the third row? Both rows can be removed, right? Answer is yes. So this is A. I want to remove the second to third rows and all the columns equal to now. So you see, once again, we could remove the remove multiple rows or multiple columns in a single by using a single command. Okay. Then let's move on to the next concept. And here we want to look at the reshaping and resizing of matrices. So this is reshaping and rearranging of arrays. Okay, now, so let's assume that we have a array which is called as existing array, and we want to put them in a different shape and different sequence in a different array. Okay, so let us assume that we want to uh, reshape. We want to perform what is called as a reshape. So reshaping is an option to put the elements of an existing array into a new array, right? With the different order of arrangement. So we can arrange the elements of a matrix into a new matrix of different size and different format. So this is what we are going to look at now under the concept called reshaping and rearranging. Okay, so what we are going to do, I'll quickly write over here. So our intention is to put the elements of an existing array into a new array in different shape, or you can use different sequence. Both are possible. Okay, so it may not be clear now why should I use it. Okay, but definitely we need these concepts for varieties of computations that we are going to perform whenever we do some projects. All right, so let's use a function, right, is called as reshape, reshape. This function can be used. It is used to change the size and shape of the array. So what this does is, right, it changes size of the array and the shape. Right. So for example, let's look at the actual scenario now. Let us say I have a matrix A. So this matrix A has say 3 rows and 4 columns. So how many elements we have? 3 rows, 4 columns means 3 into 4, 12 elements are there. See, the same 12 elements can be put up in a 2 into 6 matrix as well, right? So you see, you can convert this into, if you use a reshape function, you can convert this into matrix B. So this could be 2 cross 6 possible, right? So you see, this option we can use, right? Whenever I want, see, I have a different matrix which is C. I want to operate the elements of A with C, but matrix sizes are not matching, so I can do a conversion, right? So this is very useful because of reshaping options available, right? So let's directly go to MATLAB and see how this is going to work. Okay, so first let us create the two matrices A and B for the first. Okay, so this is so A is equal to, so I entered, say this is A. So we have 3 rows, 4 columns. Now I just want to reshape this, right? I'm going to put the result in B. So this is equal to, call the function reshape. First you specify which matrix I want to, this, right? Specify the number of rows, that is 2, and how many columns you want, 6. So you see, this is how it's getting converted. Now let's look at the order. So I didn't mention about order when we discussed the function, because it's very clear when we see the results. So you see, A gets converted into B for sure. That's fine. The size is also okay with us. So it had 12 elements arranged in 3 rows, 4 columns. Now we have our new matrix B, which is 2 rows, 6 columns, numbers of elements, fine, absolutely fine, no issues. But you see the order in which it's going to convert. It's not going to read row wise, it's going to read the column wise. This is important. See, 1, 3. So 1 and 3 is there. It fills B in the column, reading every column of A first. So 1, 3, then see 5 and 4. That's the second column. Then 5, 7, third column. 7, 7, fourth column. Then 9, 2, and 2, 1. So this is important. So even if you do in a multiple dimensions, whenever we perform the same thing in a different order, let's assume I want to create a three-dimensional array, correct? So you see, three-dimensional array basically refers to, right, writing arrays one behind other, correct? So that's its third dimension. You are going to add a new dimension to this. Let me show you what happens now. So I will create a new matrix called say C, and I want to keep the each matrix size as 2 into 2. 2 into 2 means 4 elements. So how many such matrices you can create? 4 elements, 3 such matrices, correct? Because the third dimension can have 3 such arrays. Every matrix is 2 into 2. So 2 into 2 is 4. I have 12 elements actually. So 4 elements, if you keep removing from matrix A, you can do that 3 times. So I'll show you the creation of a 3-dimensional matrix from this by using a reshape function. So let's say C is equal to, I'll do the reshaping of A, right? I have to specify X, Y, and Z coordinates. So X is 2 rows, Y is also 2. How many such matrices you can create? I know that I can do 3 such matrices, right? So see here. See, C is a 3-dimensional matrix. So if you see the way of representing, so the matrix, I'll create A here itself. Okay, so let's see the A. Now you see, uh, it's reading column wise once again. Since you require 4 elements, right, at a time, you are going to read 4 elements column wise. So first column has only 3 elements, so you move to the next column, first element will be read for 2 cross 2 for creation of a 2 cross 2 matrix. So you can see 1, 3, 5, 4. So the 1, 3 is the first column, then 5, 4 is the second column in this. Then it moves on to the next matrix. That's the matrix which is present on the second page of your array, right? So you can see it's going to read 5, 7, and then 7, 7. So they are going to be put up over here, 5 7 7 7, and the remaining elements 9 2 2 1 will also be used to create the last array over here like this. Okay, so this is important. Reshape is very important function, right? You can use it to create a variety of types of matrices. Okay, conversion of one type of one matrix, arranging it into a different size, different array, right? Different size and different shapes are possible by using reshape function. Then let's move further here, and my intention is now to focus on, okay, let's go for the transpose. Already we have seen the concept of transpose once, but I want to bring the transpose once again into picture. All right, so the next concept is transposing of a matrix. Right, I know the operator, right? We call it as a. If you have matrix A and you want to take its transpose, what do? You enter A dash, right? Now this is pretty straightforward, right? But when you use this for a complex matrix, there is a difference, right? So the normal transposing we have seen, but the transposing actually has a different view when it comes to the complex representation of in the form of a matrix. Okay, so if I use the same operator, but A dash uh, actually computes the complex conjugate transpose for complex matrices. Whenever the matrix elements are complex numbers, the A dash is not simply performing a transpose, but it actually performs the conjugation as well, right? So in real, whenever the elements of a matrix is or elements are say real, we don't see this because conjugate and the number in real are same, right? But whenever you go for a complex representation, the conjugation is also visible clearly. So let's see this in MATLAB. So let's first create a complex matrix. Okay, so that is, let's create A is equal to, this is 1 plus I, 1 minus 2I, 8, 3, 9. So this is the matrix. Okay, now normally what I expect is that when I take a transpose, columns become a row becomes column, right? So this is what I'm expecting. So but you see here, B is equal to A transpose, right? See the first element, what is here, it's changed to its conjugate. Then this number 1 minus 2I becomes an element in the column, but it is transposed. It's conjugated and then we have taken the transpose. So plus 8I has become minus 8I in the second this thing, and right, 9 minus 5I became 9 plus 5I. So because this is because a into a dash, whenever you want to do in a complex representation, always you have to perform a conjugation as well. Otherwise, right, the element into its corresponding element in the second matrix will not give you a real number, right? That's the logic behind this. Always whenever you use matrix and you multiply the matrix elements, it has to be a conjugate. So MATLAB takes care of it automatically without putting that burden onto the user to conjugate, to take the conjugate. So it automatically does. And when you do in real, this doesn't matter, because anyway there is no imaginary part. So plus 0i and minus 0i are same. So even if you perform a conjugation over there, it's not visible for us. Okay, so this is the important part about uh, the conjugate, the transpose and conjugation, right? Then moving further, next operations which are very important in MATLAB with respect to the matrices are the flipping options, right? Sometimes we need to flip the matrices in certain order, certain fashions, right? So our next intention is to look at the flipping operation. Right. The first function, I'll directly write the function names here. The first function is FLIP, flip UD for up and down, right? Up to down direction, right? So this is flipping in up to down direction. And there is another function called flip LR. LR stands for left to right. So it's very clear that the first function, flip up down, is basically applicable for rows, because when I move from upward direction to the downside, you can see that you are changing the rows. So flip UD basically represents the flipping option with respect to the rows, and the second one is left to right. When you move left to right, the columns, the rows are fixed and columns keep changing. So because of that, the flip LR is basically for columns. Okay, now let's see how this is going to work when it comes to MATLAB. So let's create a matrix first, and then we'll see how it's going to work. So let's say A is equal to 1, 2, 3. Okay, A is this. Now first I'm going to call the flip option uh, up and down, UD. I'll call the UD. Okay, so this is matrix B is equal to flip UD up A. So right, as it can be seen, the rows are actually getting exchanged over there. Similarly, C is equal to flip LR, left to right, of A, right? So the second column of matrix A is the first column over here, and the first column becomes the second column. So row wise there is not row wise, sorry, column wise there is a, right, we have performed the shifting, perform the flipping operation, right? But in addition to shifting operation, what we can do in MATLAB is a shifting operation, right? So we perform the flipping operation. Now we'll see the shifting operations, right? Whenever there is a bigger matrix, maybe your intention is not just to flip around, you want to shift by certain amount, like first row becoming second row, second goes to third, third goes to fourth, and fourth comes back to the first, like this maybe you want to perform. So in such a scenario, what we want to do is not flipping, it's called as a shifting operation. This is shifting operation, right? So this is to perform, say we want to shift the elements of an array by certain number of positions, right? And the function used is called as CIRC. It's CIRC for circle and shift, because it's always going to happen in a circular fashion. All right, I will show you this now. For example, let's write, this is the example. Let me give the example and let me explain what exactly is going to happen. Then we can see that example on the MATLAB window. All right. So let's say I want to call, say, matrix B is equal to CIRC shift, circular shift of the elements of matrix A. Then what you write here, the second argument of this function is going to tell you what you are going to perform. So for example, I'll write, say, 0, 2 here, right? This 0, 2 is going to tell MATLAB that perform the circular shift to matrix A by shifting the rows by 0 places and shift the columns by 2 places. Columns will shift, rows will not change. See, this is circular shifts. When you consider a circle and rotate something, we are expecting something goes up and something moves left, right? So you see, rows should change, columns also should change when you actually perform a circular shift. But definitely you can indicate that don't change the rows by specifying the row index 0 in the circular shift. You say that 0 over there, right, corresponds to the row change. The columns position, if you put something, it indicates that okay, you are going to perform the columns shift. So I'll tell you, I'll write here itself just to make sure that what this does. To means shift columns. So whenever I write a positive number over there, that is to right. If you put this as -2, this indicates that move it to left. Okay, so this is positive. So whatever you write here, that is the shift, uh, the specific whatever elements you have, right, in this direction. So right is positive. Okay, I'll write the positive and negative later. So let me write shift the columns and don't shift rows. That's what is the meaning here. No shifting of rows. This is what is an indication, right? So if I have let me write something like in general. So this is the generally, if you write something like this, say that is circ shift of A, comma, I'll write it's a vector containing the, say this is X and Y, something like this we write, correct? So let me write what you are supposed to do if you want to perform right shift, left shift, up shift or down shift. Okay, so let me talk about Y first. Y, you have three options. So you can see if Y is a positive number like this, you can see this is 2, whatever value we have written 2 over there. Positive means this is to right, in the sense columns will move to right by so many locations. If this is 0, no shift of columns. And if you write negative entry over here, this is to left. I want to shift it to left means it is negative. Y value becomes a negative. Okay. Similarly, let's talk about X now. So X also has three options. So the first option, if it is positive. So what happens when you enter X positive? Okay. This means it is uh, downwards, right? So default is downwards. You write a positive quantity, it will move, the matrix rows will come down by so many amounts. So if you enter 2 over there, first row becomes third row, right? Second will become fourth because moving downwards by so many amounts. So if it is 0, this means no row shift, like the previous case. Okay, you made it 0 for column, means no column shift. And if you write this as negative, it means you are going to shift the rows up, upwards. So if you write a -1, one row up, so first row becomes the last row, last becomes one before that, and so on, right? So this is what is going to happen whenever you use a shift function. Okay, let's do this in MATLAB. Okay, so I will create a matrix now. So say A is equal to, this is I create a 4 into 4 matrix. And my first command is I create a matrix B by performing circular shift of matrix A, right, in a specific way. So you see, this is no change in the row orientation, only the columns I'm going to change, right? So I just write 2. Just see, the it's positive means what? Positive means right shift, correct? Columns will move right by 2 positions. So see, the third and fourth elements of first row became first and second because this is circular shift. Are you okay? And whatever moves out will come from the other side. So the 3 and 13 which went out when you shift, it came from the other side. So same thing happens with the all the other elements of the matrix A. The second and the third and the fourth column will come back from the other side, and they are replaced in the first and the second position. Okay, like this. The other example which we considered is C is equal to circular shift of matrix A, right? Now let me assume that I want to move upwards, right? So what I do, I will write this is -1 space 0. I'm not going to touch I'm not going to touch the columns, but simply rows. So just see, we had A over here, it's this A, and the second row is moved up, right? So first row goes to the last row position. So you can see that. So first row was 16, 2, 13, and 3, which actually are here. And in the sense, first row has no upper position to go, so it will go to the last. Since it is a circle, right, it will form a circle. Whatever moves up will be coming back at the bottom, right, will become an entry in the last row. So this is how it is. Definitely you can use both orientations and you can do the calculations, like say I'll say D is equal to circular shift of the elements of A, right, in a specific way that this move it downwards by say 2 positions, and I don't want to move to right, I want to move to left, say left by 1 position. This is definitely right. So you can check, this is the result, right? We can perform one by one step and we can check that yes, this is what is going to happen, right? Compare this with A and you will come to know, right? So everything has to move to left by one position, right? So left by one position means this 16 should come to the uh, last position. Then I'm saying that move it downwards by two positions. So whatever was 16 here, that 16 should come down by two positions. That's why you have this as answer. So everything moved to left, uh, moved, everything is moving down and then right. Okay, so you can verify. So circular shift is another important operation that we use in. Okay, then after shifting, we have another important command in MATLAB that is called rotate, right? So I don't want to touch the central element, but I want to rotate my matrix in a specific fashion. This is very useful in case of images,